sorry about the technical difficulties there. My name is DJ Spry. I am a principal engineer in the SDN and Open Networking product group at Dell. I apologize. I don't speak Dutch, and I barely speak English, so hopefully we'll get through this all right. So I'm going to talk about a couple use cases with the OpenStack and some of the SDN use cases we had today, both with Verizon and some other use cases that we had. Just real quickly, I'm just going to level set what open networking is for Dell, right, and what that means for Dell. So within Dell, open networking is a larger umbrella term that's based on many SDN principles, but falls under 3 pillars, and it's all based on disaggregation, which allows choice for customers, choice in hardware and software and technology. And it's broken down into 3 distinct silos from a networking side, where we have disaggregated control plane from forwarding plane, so things like OpenFlow technologies. We also have separation or disaggregation of the overlay protocol, so things like Metacora, Nuage, PlumGrid, OpenContrail, NSX, those sorts of concepts where the virtual network is disaggregated from the real physical network. And then we also have disaggregation of the operating systems. So unlike traditional networking, the way we all are aware of networking today, if you buy, say, a Cisco or a Juniper, the operating system is locked to that vendor, unlike in the compute industry where the software is independent of the hardware blocks. So everything we do is based off of disaggregation because it lowers price points, allows competition and flexibility for customers, which is sort of talked about here. So just to kind of give a level set, if I compare it to the compute industry, where depending on what it is that you want to build, you're not going and changing that Lego block, right? It's an x86 component. So if you wanted to do something like OpenStack, you pick your Linux distribution of choice. If you wanted to do virtualization, you can run VMware. Or if you wanted to do like an Exchange server, you run Microsoft. But it's not like you're buying different compute to do all of those things. You can use the same compute element to build upon whatever operating system that you want will dictate whatever application you're trying to build. So I'm not going to talk about all these, but just give an example of the ecosystem that we have. This is some of our partners today. I'm going to talk about Big Switch Networks and Cumulus Networks, both of which are here at the show. So if you want more information afterwards, you can go and talk to them in some of the demos. Excuse me. And a difference between the compute industry, where in the compute side of the house, Dell doesn't play in the operating systems. In the networking industry, we actually do have our own operating system, so it's a little bit different where we compete in that space for an operating in the network side of the house. But I'm going to jump right into it. Just everyone's here. Everyone's, I'm assuming, familiar with OpenStack and the goal of it, but we've done there was some market research about, why someone would actually run a private cloud, or what are some of the values instead of just moving everything to, say, like AWS or moving everything offsite, is that there's actually, especially depending on the applications, a lot of return on investment you can get. And so this one here, these slides will be disseminated, but there is a Forrester report that said over 3 years, 111% of savings. Or, for example, I visited a customer not that long ago. It was a fairly small customer. They were running some big data and Hadoop applications. They were spending $500,000 a month on AWS, and it was just lost. So they were trying to move a lot of that back in-house because it was just, they weren't getting good return on their investment. So this is just some more stats. I'm not going to go over this. I want to get into the use cases, but really it's talking about everybody wants the cloud and how much savings you can make. Again, another slide about how we can, I think this was a 5-year period or a 13-month payback for the investment by running things in-house. So really just talking about, how powerful something like OpenStack is for private cloud. Ooh, this is actually the wrong slide deck. This is the next one, so that's my 3:30 one, if you guys want to talk about food. So let's do this one. It's all the same stuff. All right. Whoop. Skip through. All right. So this is what this slide is. It's kind of a busy slide, but with underneath Neutron for the networking portion of OpenStack, This is sort of the lay of the land. So when you build your OpenStack, you have some choices of some vendor plugins because, as many of you know, OpenStack gives you just enough to get going. But when you start tackling things like scale and like NFV deployments, Neutron sort of has challenges, right? And so, what this is laying out is underneath OpenStack and underneath Neutron, there's the ML2 core drivers, which is sort of the separating the what from the how. And ML2 is mainly focused on layer 2 networks, right, or multi-layer 2. And then you have these core plugins. So today I'm going to focus on Big Switch has 2, and that's the Verizon use case, and I'm going to touch briefly on Cumulus. But as you can see here, we have a lot of different options of which we can help customers build their OpenStack network, especially to solve some of the challenges around Neutron. And it can either be from basic ML2 core drivers or to full core plugins which replace a lot of the back-end components of Neutron, which is where some of the challenges come in. And they're both overlays and non-overlay solutions. So a lot of these here are overlay networking, where Big Switch is actually very unique in its use case where it is a core plugin, but is also tying in the physical and the virtual. And I'll talk about that. Okay, so this is the big one. So this was announced publicly at the OpenStack Austin event. So it's the largest OpenStack NFV deployment on Earth. So it's across all 5 of their data centers at this point in time, and I'm going to actually share a bit of roadmap of where we're going and where Verizon is going and taking this and pushing it out further within their network. But it started about a year ago, and they had some key tenets that they wanted to solve. They wanted to move into this next generation of networking. They wanted to be able to deliver any app at any place at any time to any consumer. And they wanted to, it had to be, so they had some use case, or they had some tenets, right? It had to be resilient. They didn't want to have bottlenecks. They had some problems with Neutron, and they had to, especially when we're talking about rich NFV services, everything from DPIs to DTP, mobile networking, load balancers, all those sorts of services, how they were going to efficiently deliver those. It had to be easy to use. They didn't want anything over complex, and they wanted a very tight coupling, right? Because at the end of the day, they want something that can be managed. Or when something breaks, they want something simple that they can get into without a lot of technical debt and manage it. So the first principle that they decided on was this core and pod design. Sorry. And so this is very useful in a few ways. If those are familiar with like the MSDCs or the mega scale data center guys, for instance, Facebook's Altoona project are built on this very same philosophy. And it's using fixed form factor switches, using spine and leaf topologies, and building in pods. And what that allows you to do is you can build applications, you can build networks and environments specifically tuned for that application they're going to run. And it also allows you to iterate pretty quickly. So you can build a pod, and then while that pod is running an application, the next generation can be built. So it's very similar to Microsoft builds their data centers. They do cubes. There's always one running, one being built, and another one being designed. So they have this very, iterative process. So they always stay at the cutting edge. They can always have this fast-moving network. But it also enables competition. So just because in this case, in this pod for this NFV deployment, doesn't mean that the next pod has to be Big Switch. Because they can now, for the next pod or the next application, have vendors compete with things to pick the best choice. And as a matter of fact, there was another project also using Dell networking and open networking hardware with another operating system, Cumulus, which I'm going to talk about, that didn't involve OpenStack, but it was a completely different pod that they used to disseminate their video on demand content. So it's called OnQ. So you can watch videos from your phone. That application was delivered with a completely different OS and another pod. So this is the architecture. The SDN architecture so now I'm looking at Neutron down. The Big Switch architecture for them solved a couple different things. One is the operational complexity. So it is a SDN controller-based network. So what that means is no matter how many top-of-rack switches that you have, it's managed as a single entity. So through a single controller, it's either GUI or CLI, which is very nice for normal networking people. So it's this, It's tough sometimes to get networking guys to move away from CLI. So it provides them a CLI with syntax and usability and terminology that they understand, so to continue that day-to-day operation. But it also, in addition to the GUI, both the CLI and the GUI are clients of an API subsystem. So what that means is anything that you can do in a GUI and anything that you can do in a CLI, both have a RESTful API call. So for Verizon, what that meant was that they can then extend some automation capabilities and begin to drive the fabric through more automated techniques, in addition to what already is done with inside of the OpenStack Neutron plugins. So they're very unique. So all of the other plugins that exist in the market for SDN controller-based networking is what they're doing is they're controlling the vSwitch side of the house. So the vSwitches that reside on the compute nodes. But they don't do anything with the actual physical network. That's a whole separate thing that you have to stand up and you manage, and usually everything else is overlaid on top. Big Switch is unique in that they also run their software not only on the compute nodes, but also on the top of rack switches. Excuse me. So what that means is now you have one common endpoint that's tying both your physical and virtual together through one common interface. So when it comes to operation management, doing things like service chaining, you can see everything from your virtual infrastructure to your physical infrastructure, and it's zero-touch provisioning. So when you put a new top of rack in, you expand that compute, you expand your OpenStack cluster, you want to expand your NFV capability. It automatically builds, it plug it in, it knows what it's there, it automatically joins the environment, and then from an operational perspective, you can see everything from physical to virtual all at one time. It also, some of the problems with Neutron is, I'm going to talk about on the next slide, there's some scale issues, there's some performance problems, and there's the problem where you don't get hardware offload, right? Where depending on what you want to do, you may want to handle that networking capability on the top of rack switches and leverage real hardware instead of pushing that into the compute. So here are some of the lessons learned. OpenStack is really good, but it's not good enough for something like network functions virtualization, especially for carrier grade, where you need to deliver a rich number of services. There are single points of failure, hairpin scales, and one size does not fit all for your NFV workloads, right? So you might have a requirement, again, for say DPI, and you may want to run that service or a service chain or that capability, on the compute node. Or perhaps it might be more beneficial to do that in a hardware, right? You want to take that service chain and take it to a real physical firewall. And OpenStack automates some, but not all the NFVs. So together with Big Switch, Dell, and Red Hat, and a lot of this has been upstreamed, but also some of it is specific to the Big Switch architecture here, allows you to, I'll talk about it, allows you the capability, more flexibility to put certain workloads in certain locations. So to give you an idea, to put some real meat around this, is that the packet hairpinning and routing for NAT and floating IP functions. In the Big Switch, because again, through a single controller and through a single interface, it converts and traps those Neutron calls that involve these functions and distributes it across the entire fabric. So now your gateways are your first top gateways. You can leverage things where your default gateway actually resides on the top of rack physical switches if you need for between two compute nodes. That is going to, instead of going through the single network node, where generally there's a lot of hairpinning to send the traffic to the compute node and all the way back, and then there's complexity around the DVR capability. All of that state is distributed. So with OVS, there was some problem with non-IP traffic. So what they've done is, again, they were able to take that Neutron APIs and distribute it amongst the fabric and run some of this stuff down into to Virtual Switch Lite, which is the operating system that's running alongside OVS on the compute nodes. And you can also begin to do things. They have the Project NF vSwitch, which is a DPDK-enabled vSwitch capability in the compute node. So you can really begin to drive high performance throughput on the compute node within OpenStack through a single controller. There was a problem, so they are a service provider. They do a fair amount of service with LTEs and wireless. So GTP is a tunneling protocol. Verizon had a specific use case where they were leveraging GTP, and there's a problem with some hashing capability. So again, Big Switch made some modifications in their software, and were able to, using the tunnel endpoint ID and the spines and leaves, to create a more efficient hashing algorithm for the service provider. So in other words, they were able to spray those tunnels across the entire fabric to get better utilization of everything within the data center, and not pinning things to specific flows to create hotspots or certain single points of failure. And the other one is with regard to VXLAN. So VXLAN, it's all over the place now, but there are some performance issues if the compute node is doing the VXLAN. You may be able to overcome some of those things with some offload capabilities within NICs, but what they've done is they've allowed you to do VLANs, traditional VLANs within the rack, and the actual top of rack switches are the ones doing the in-cap and decap for the VXLAN capability. And when you do that, you can also use the VXLAN as the tunnel to stitch multiple pods together for the workflow. So to give you an example of what this actually looks like for them, again, because they have this premise, they want to deliver any app at any time, at any service, at any location. So within BCF or within Horizon, because through BCF Horizon, these extensions have been added through Horizon, so your customers can actually build this topology. And what it is not, in addition to the provider managed chain, so you being a service provider can have certain managed chains where you say, I always want a firewall at this specific application or between these policies. But you want to give the capability for the tenants to go and build whatever they want to build. So this is an example of a 3-tiered application that a tenant built. And it allows them to mix VNFs and tie them into either physical devices or virtual devices. And every tenant has their own instance of the same, of firewalls or the load balancers, right? They have their own independent instances. They're not using some shared resource. So you can have the customers build anything that they want to. And knowing the fact that each resource is placed and handled at the right place within the network, either on the compute or in the top of rack. So it's a lot more flexibility and capabilities you would get otherwise. So the other thing is that with service providers, it was a bit of a change of mentality, especially Verizon. Is it typically it's like 5 nines, or what is your MTFB for this one component, or how long is this one component going to run? But more importantly, when you start talking about private cloud and applications, is how resilient is the entire stack? How resilient is the system? What happens when one thing fails? So they took advantage of, for those that don't know, this chaos monkey testing originated out of Netflix. And what Netflix does, they have this script that runs out, and it breaks things on the live network, all these random things to figure out where there's problems. So they can find them before users find them, so that when I'm downloading movies or watching movies, you don't find them and complain. So this is an example. This was actually Iran. So it was 1,000 neutron networks. You can read 32 spines, 16 rack deployment. They failed physical components, virtual components, logical components. 640 failures in 30 minutes with no impact on the application. So that was very, very important to them. So as a stack, when somebody like a service provider for Verizon or any of the service providers that are here in the Netherlands, you want to make sure that when you deliver this service that it's going to be resilient end to end, not single components, but as a platform. So this is a bit of where we're going. And again, it doesn't mean that it's a beauty of the pod-based design. They get to compete solutions from different providers, but this is sort of where they're going as far as being able to deliver that NFV resource to everywhere that Verizon touches and to every customer. So this is you guys or guys, will probably be maybe the first time some people have seen this is that they're moving this service also out to the central offices, which means that they need NEBS compliant software for service providers. Beyond that, there is a desire that they had. They say, look, this is great, we have it in our data center, but we want to push that further out to the edge. And the further out to the edge it goes, the smaller that footprint generally looks. So they wanted to take advantage of more virtualization solutions. So the controllers, the physical SDN controllers for the network, they have virtualized running on the infrastructure. So you can provide the same sort of NFV capability at a reduced footprint. We're talking within 4 RU of footprint for the network side of the house that they can deliver all of these, 1,000 VNF functions. This next one is the one that's being worked, and this is actually using Metro and optical WAN. So if you picture essentially services running out again at the client-based solution, and the top-of-rack switches and the compute nodes and the storage actually would live somewhere else, and they're leveraging optical DWDM backhaul back into the main central office. And so this is where they're going here in order to, again, provide remote POP NFV. So it's really just giving them options that they can deliver that service anywhere at any time within OpenStack. So I'm going to give you another example. So I mentioned earlier that we also have a deployment inside of Verizon based on Cumulus that they use for their video distribution content. But I'm going to show you another project that we did, again, with Dell and Red Hat, leveraging Dell networking solutions, open networking solutions, but using a different operating system on the network side of the house, and that one's Cumulus. And the point of this was to show that, can I build an environment, can I create an OpenStack environment completely virtually? Like, instead of going out and buying all this hardware and finding out if it's going to work or not, can I build it all? Can I automate it all? Can I test my scripts and make sure and have confidence that when I deploy this thing in real life production that it's going to work? And can I do it based on one common interface, like Linux in the data center? Can I use the same tool sets that my server guys are using for this infrastructure as code? Can I use Git and Ansible and all of these sorts of things, not only for the compute side, but for the network side of the house, to have one common interface that everyone can, deploy on? And can I do it completely with L3? No one likes VLANs, no one likes L2. That's like a bad word in networking today. And can it all be deployed within the Red Hat OSP director? So to give you an example of what this looks like, it was 18 switches, 300 compute nodes, 9 physical racks, and this was built in Santa Clara? Santa Clara. It's built in California. But anyways, this is what it looked like from an infrastructure side of the house. And if you were to picture it, this is what it looks like. So it was layer 3 networking all the way through and through, even actually all the way down to the compute nodes. So Linux actually running on the compute node, the same distribution that runs on the switches is running there. So that means from your tour, you could actually see BGP adjacencies all the way end to end. So you could get on one compute node and easily track where that compute node was talking through BGP. At the end of the day, this is what happened. So the entire 100% of the stack was Linux, 100% of the stack. The entire thing was prototyped virtually. Actually, all of these GitHub are on GitHub. So all the playbooks that they used, everything that they did in Red Hat, all of it lives on GitHub for anyone to take a look at and to grab. It was built in 15 minutes without any proprietary APIs, a completely open source solution. There it is. The entire network was built in 15 minutes. And the entire infrastructure was done in 6 hours. So before, when we would go out and talk to customer, how quickly we could stand up an OpenStack environment and how easily we can make it for them, we would tell them we could do it in we could tell them we could do it in a day or maybe a day and a half, because no one believed us that we could actually do it in 6 hours and 15 minutes. And there's a video on YouTube also, if anyone wants to see me afterwards, I can point you to the video. But the whole thing, again, is as infrastructure as a service, the network becomes part of the workflow, becomes part of your compute workflow. It's not another thing that you have to touch and manage in another skill set. It's just Linux. And this is sort of just a slide, right? Highlighting that fact. The same tools and the same skills it would take to build an OpenStack is the same tools that we want you to manage from a networking point of view. And Cumulus has it, because it's just an operating system, it's agnostic to the SDN controllers, unlike Big Switch. So I mean, it's enabling choice. I'm not going to say that one is better than the other. It's more up to the customer, their application workflow, the people that you have on staff, how skilled you are, and what it is and comfortable that you're trying to build. And for Verizon, it's based on the application, right? And for the most, everyone in the room, I'm sure it's going to be somewhat of the same thing. This is what I like to call an I love me wall. So this is just more customers that we've done similar things with. And then we put it on here because it's got numbers, real tangible numbers that you can look at and reference later of how much they've saved, but also to kind of give a breadth of where we're doing this at. It's just not at these largest service providers. It's also, in hosting companies. It's, within smaller data centers, fuel, industry size of the house, and even a lot within academia as well. So this is just some of the closing slides. At the end of the day, what we're here for and Dell is here for is this open and interoperable solutions, right? I'm not here to say you must consume OpenStack in this fashion. We want to give you choices, and we want to work with you, to find the right solution depending on what your need is. And at the same time, it's lowering the TCO so that you can get a better ROI that we had in the first slide, right? It's not for the fact that we don't want somebody to go into the OpenStack world and struggle with a lot of these concepts that we may have already have seen or realized or ran into with customers. Is to help you guys be successful in your OpenStack deployments. In a later presentation, I'm going to go through some of, we have many different paths to guide customers to OpenStack. And in one of the later sessions, I'm going to talk about all the different offerings that we have. And this is a very busy icon slide, but this is to show really the full menu of capabilities that we have within OpenStack. This is just some of the NFV solutions. These are some of the partners that we have. So, if you want load balancers, firewalls, DPIs, actually routers, virtualized firewalls, all these are the NFVs. This is some of our other operating systems. But at the end of the day, this is sort of a real quick glance at just our capabilities. And that's it. I think I'm pretty close on time, if anyone has any questions. Sir?
You mentioned deployment in Verizon.
Yes.
Is that based on Dell hardware as well? Or?
Correct, yes. It's a Dell stack through and through.
Because does Verizon have multiple OpenStack deployments then? Because there's also a Cisco using Dell.
So I'm not going to say that there's not, because it's a massive organization. I can say that everything that they're doing, all of their new deployments and anything for their NFV, anything for the video content hosting on their current architecture is Dell hardware. Now the operating system obviously is going to change, but everything in that case is Dell. But they're a big organization. They have a little bit of everything. Anything else? Bueller? No? All right. Thank you, everyone, for coming.